In the previous video, we learned about periodic functions, and we learned how we can describe a periodic function in terms of its period, midline, and amplitude. And a periodic function that is shaped like the one that we saw in activity 2 is actually called a sinusoidal function. And we will use functions like these, sinusoidal functions like these, to model different types of phenomena. Let's look at example 1 on the next page. Here we have a function that models the height, h in feet, of the tide above or below mean sea level t hours after midnight. So imagine you go out to the coast and you measure the sea level. And with the tides, as the tide goes out, the sea level goes down, and as the tide comes in, the sea level goes up. And this behavior of tides can be described in terms of the same type of function that we encountered before. So let's answer some of these questions. The first one is the tide rising or falling at 1 a.m.? Well, so t equals 0 is midnight, t equals 1 a.m. is about here, and we can see that the tide is on the way in. So the sea level is rising at that time. So the tide is rising and we know that because the graph is increasing. At t equals 1. Now the second question they're asking us is, when does low tide occur? Let's see, so the lowest sea level that we see happens right there. We have the minimum point on our graph, and that happens actually twice. So we are reaching the lowest point twice, and tracing back to the time when these two low points are reached, we can see that's about at t equals 9 and at t equals 21. So that is about 9 a.m. and 9 p.m. So low tides, or the low tide, occurs at 9 a.m. and 9 p.m. And we see that from the graph because the graph achieves its minimum output values at those two times. So the graph achieves its minimum output value at t equals 9 and t equals 21, which correspond to 9 a.m. and 9 p.m. Now we learned previously about the amplitude of a function, and so here for part C we want to know what is the amplitude and what does it mean in the context of this problem. So going back to the definition of amplitude, it is the difference between the high point and the midline. So we also need the midline. Now the midline, and that's what part D is asking us about, in this case it's this line of symmetry right at t equals 0. So actually let's answer that question first. So the midline is the line h equals 0. Okay, back to the amplitude then. The amplitude is the distance between the highest point and the midline, so it's this distance right here, and we can read from the graph that that is 20 feet. So the amplitude is 20 feet. And in this problem, the amplitude represents the maximum amount that the tide deviates from the mean sea level. So it's the maximum amount that the water level will always be, the water height will be above the mean level and below the mean level. So the amplitude represents represents the maximum amount that the tide deviates from mean sea level. Okay, so the midline, we already found it. It's a line, h equals 0. And in this case, it represents the height of the water when the tide is at mean sea level. So mean sea level corresponds to height h equals 0. Okay, so this represents the height of the water when the tide is at mean sea level. We could also talk about what the period of this particular function is. They didn't ask us, but we could see how long does it take for one complete cycle of our function, of our graph. And so we're going up, we're coming back down, we're going back up, and it looks like then we are repeating. So the period in this case would be 12 hours. So the period we can see is 12 hours.